delve into the more in-depth stuff on the BCM now, but we're also discussing part of the RF hub at this point. So we're back with our old diagram here, our just generic, quasi-generic starting system for something equipped with the FOBIC, the keyless ignition, all that. So as we discussed before, we were just in the RF hub looking at our data PIDs. We were looking at our gated park switch here. Our antennas here. We're recognizing the key. Remote start we didn't touch on, but remote start, it would actually go through the same process as when I was trying to manually start it with the push button. So we know that antenna was working as well. Clutch switch, not applicable in this point, but we delved into the RF hub pretty well and we saw pretty much everything we wanted to see. So now we're going to delve into the BCM and learn a little more and see how things are going to work. So this is actually the factory procedure for a no crank. Let me scroll here. A no crank for a BCM equipped vehicle. So this is where the, getting into delving through service information quickly and efficiently comes in. And this is something that I rely on heavily. So let's go through. We're basically just going to highlight the stuff, what we care about, what we don't care about. So keyless ignition node here, we know about. RF hub, we know about. Uses a keyless go, start, stop, push button. We know about that. When the operator presses the start, stop button on a keyless ignition, FOBIC is validated wirelessly, which we proved out, and that's done through the RF hub. If the FOBIC is recognized as belonging to the vehicle and is inside the vehicle, the system allows the ignition state, so we care about this, to be changed between the lock, accessory, run, and start states. We proved that out. We were able to do that. So we're feeling pretty confident that not only is our RF hub working appropriately, but it's also sending those messages over the bus to the BCM, and the BCM's recognizing them. So now we got LED operation here. So we have LEDs in the ignition module and start-stop button are a visual indication of the ignition system and button used to aid the driver. The logic for the LED control is implemented by the RF hub. So now we know that push button and which light is illuminated is implemented by the RF hub. So it's a communication back and forth. That start-stop button contains 4 LEDs. To back up for a split second, we know it's implemented in the RF hub. So we know that this is an indirect input to the BCM, indirect versus direct. So we're dealing with network comms here, and if we've already proven out in the RF hub that this is good data, and we are seeing within the BCM, we hope to see the same thing, we can feel pretty confident about the programming, module state, everything else of the two of them. So we have an off indication, we have an accessory indication, we have an on, and we have an ignition switch indicator, which is the backlight. Now we do have all of those. So LEDs indicate the vehicle ignition position and are driven by CAN bus signals related to the ignition position. Once again, indirect input. The center, and this is kind of where I get into finding the little bits of information here. Generally, I would scroll through this a lot faster, but we're learning here. The center LED will blink if there is a concern with the ignition switch, if there is a related concern there. So basically, if there is a plausibility check or a mismatch between the RF hub and the desired ignition state based off of pressing the button, we'll have a blink there. What does that tell us? Well, we've got no blink at all, so that's just yet another way to prove out that the RF hub and the BCM are communicating and they're in agreement. RF hub will log a DTC indicating an incorrect ignition status value is present. In this state, ignition status is unknown. So we actually had a data pin in there that was ignition status. We never went to unknown. So once again, we are proving out. We've got good RF hub. We've got a good FOBIC. We've got good comms to the BCM. BCM's recognizing everything. So you see how we're going through service information, confirming what we know, confirming what we don't know, and going from there. We're building off of what we've seen. We're using this to analyze data and go further. Keyless Go feature requires the vehicle to be equipped with an EVIC display for prompts and status info. Display messages are service, fob not detected, fob left vehicle, not in park, push brake pedal, and push button to start. Well, that's what we're getting. So we realize that we're seeing a lot of the inputs we need to see, and it's thinking that it should be able to start. Push clutch pedal. It's an automatic, so we're not worried about that. Vehicle not in park warning, not getting that. So between not in park and vehicle not in park, as well as push brake pedal and push button to start, those three kind of give us various indications of the status of our park neutral switch, or at least the input that the RF hub and the BCM are getting, which once again are indirect inputs. But that gives us some diagnostic strategy. We're not getting any of them. So if we're not getting a not in park or a vehicle not in park warning, kind of the same thing. I wasn't actually able to duplicate the two separate messages, but point being, if we're not getting a display message, can we feel fairly confident without delving into further testing on the neutral safety switch that everything is recognizing this neutral safety switch correctly? I think we can. I mean, for the purposes of this, I always like to confirm, but I think that's a good way, once you know these systems, to be able to say, hey, we're not getting a message in the instrument cluster here, and the BCM's not flagging a message, so we're once again seeing a good park neutral input. And here's where we're dealing with the rest of the BCM and RF hub. A few things that must take place before the starter relay can apply voltage. Below are some key points to check. BCM requires two signals from the RF hub. Voltage on the F20 circuit is one of these. It can be monitored in both the RF hub and BCM data displays as the ignition run start under the sensor value. So now we've got a way to confirm one of our inputs. We can see it in two different modules. And we have the actual name of the data pin. It goes a step further to tell us the runner start position voltage on the circuit should be at to or close to battery voltage. Simultaneously, the RF hub buses the ignition run start status to the BCM, so indirect input. The BCM monitors this bus input information as a secondary verification of the status. Once again, the bus messages can be monitored in the scan tool in both the RF hub and BCM data displays. So we can run a plausibility check between two of those to see if we may have corrupted CAN communication, corrupted software. The F20 circuit voltage and the bus ignition run start status message must agree to enable starting. Once the vehicle is started, the loss of only one ignition signal will not cause the vehicle to cycle off as long as the other feed still indicates a run status. So we know that once we jump pins 87 and 30 on the starter relay while pressing the button, this vehicle will run and it will continue running. So looking back at what we've already witnessed and what we've proven, now we look at our service info and it tells us that even if we lose one of our ignition signals, the vehicle will continue to run as long as the other is in a run status. So now we know at least one of these signals has to stay in a run status. So that kind of gives us some more direction, gives us a little more information to work off of. The RF hub also requires an input from the gated park switch hardwired, direct input at this point, not a bust message, and the OK to start CAN bus message from the TCM, crank enable. So see, we get a gated park switch, which is a hardwired input into the RF hub. We looked at that in the previous section. And then we also look at the OK to start TAN bus message from the TCM. So we're going to want to look at the TCM as well. Diagnostic aids. And this is just kind of generic flow chart stuff. Communication to all configured modules. The condition is currently present. TCM, PCM, RF hub, and BCM are the latest calibration levels. Difficult to do when you're dealing with a modified vehicle, and that was something I was concerned about and working around. I could update the TCM, the RF hub, and the BCM. I could not update the PCM because it had a tune to account for the ProCharger, different fueling strategy, everything else in there. So now I've got 1, 2, 3 out of 4 that are updated to the newest software and one that is not, but I can't modify without risking other things. So that kind of throws a wrench in the works, and you have to work around that. No active DTCs. There are no applicable recalls, no applicable TSBs, no PCM inhibits, which is why we're actually going to go from the BCM to next we're going to go to the PCM. FOBIC's complete function and operation is correct. We've proven that through the RF hub. Battery cables and connections are clean and tight. We know if we jump 87 to 30, this thing cranks over fine, fires right off. We can be very confident that the cables and connections, no open fuses. So far, we've seen no indication of that. Battery is fully charged. Once again, this goes back to that all battery cables and connections are clean and tight. Cranks over really well, fires up. Engine rotates freely, once again, proven it out. Any aftermarket equipment wiring that has been installed is operating correctly, And I mean, we can get into the starter relay here, but it's your generic flow chart. Pin 30 is a constant battery feed. Starter relay coil is supplied power from the BCM and a controlled ground from PCM to pins 85 and 86. And let's do it this way. Energize the relay once the parameters for the ignition switch position and status and all inhibit monitors, clutch switch, RPM, etc. Pins 85 and 86 are used to control the relay. Which pin is supplied power and ground can vary. We've already gone through that. Pin 87 is our output circuit to the starter solenoid. That's actually our starter solenoid high data pin. So we can monitor that to see if it's expecting to see and monitoring to see if there is a 12-volt output on that starter solenoid wire, which we were not seeing. Check RF hub and keyless ignition node operation. We already did that. Starter relay check. We did that first. That was our way of splitting the system. Starter relay input. Once again, beginning, we started there. BCM ignition status is where we're going to be going. We're going to look through all of that and go from there. And then we're going to go to our PCM and build off of any possible inhibits from there. And then they have you go through a bunch of other steps that we really don't care about right now. So now that we've gone over how the BCM and the RF hub interact, let's delve back into the BCM and see what data PIDs we got, make sure everything's agreeing, and then we take our next step to the PCM. So now that we've gone over where we go from the RF hub to the next step, which is going to be the BCM, let's take a look at some of the data within the body control module. So we're going to pull that up here. We're going to go into our data. Once again, we got to keep in mind direct inputs, direct outputs, indirect inputs, and indirect outputs. How the network topology is set up, how the call and the responses are set up, how everything's communicating, how everything's verifying plausibility of any given switch, status, anything like that. So what we're going to look at here is, we're just going to scroll through bit by bit. Like I said, not being intimately familiar when I started on this vehicle with this particular ignition system, this starting system.
I was scrolling through and looking for anything out of the ordinary or anything that I may want to research further. So we're looking at ambient air temperature. I always like to do a temperature plausibility check for anything. It's quick, easy, and you're in there going through data anyway. So 93 degrees, which is about what it is in the shop here right now. Interesting one here, which people may not always think to use, is our center high mounted stop lamp. So right here, we're off. I depress the brake pedal. And we go to the on position, which is letting us know once again, that's another proof that the BCM in this case is receiving the brake pedal switch input. Very important to being able to start it. It doesn't see brake pedal. It doesn't crank. What else we got here? We have... Let's see what we got here. Headlamp, ignition, run, accessory 1. And we're going to pull up ignition, run, start. Ignition, run. And ignition, run, accessory 2. And one more. Ignition switch status. We want to see that our ignition switch in this case is changing how we expect it to. In this case, we're going to depress the brake. We're going to hit the start position, and we're going to wait for data PID changes. So we saw that we went to the start position. It went out of the run accessory position. It went out of the run position, as well as run accessory 1. So we see everything's looking good there. So let's minimize those for right now. And let's see if there's anything else that we want to be looking at. So right here we have our park reverse neutral drive status. And I believe, let me scroll through here. And our starter solenoid high status. So we're going to jump into that in a minute here to describe why we have a data PID for starter solenoid high. But we do see that our park reverse neutral drive status, we're in park. I'm going to switch over to reverse. And then we're going to go to neutral. Then we're going to go to drive. And we see that we have changes in our data PID, which once again verifies our park neutral switch, or our transmission range switch in this part. It's a little more complex than just a conventional park neutral switch from back in the 60s, 70s, even 80s. And so now we're back in park. We're going to hit our push button again. And we have no change in our starter solenoid high data PID. So we're going to hop back into the service information and take a look at why that may be and what that data PID actually means.